Hello, class. Yeah, welcome back. We continue with conditional probability. So we define conditional probability as the probability that an event occurs based on a condition or given that another event has occurred. An example could be, what is the probability of you taking the ATU 106 exam given that you registered for the course? So, and then another example will be, what is the probability of taking the ATU 106 exam given that you did not register for the course? If you look at the second example, the probability of taking the ATU 106 exam given that you did not register the course is zero because you cannot take the exam if you did not register the course. However, the probability of taking the ATU 106 exam given that you registered for the course is between 0 and 1 because it depends on you if you will show up for the exam or not. So we define two events, A and B, and we define the probability, the conditional probability of A, given that event B has occurred, as the probability of A intersection B all over the probability of B divided by. All right. So in my initial example, A will be, say, the probability of taking the ATU 106 exam, and B is the probability of registering for the course. No, A is the event of taking the ATU 106 exam, and B is the event of registering for the ATU 106 exams. Let's take an example to ground our understanding. A student rolls two six-sided fair dice. The two numbers that appear on the top face of the dice are observed. Calculate the probability that the product of the two numbers is odd, given the sum of the two numbers is between 6 and 8 inclusive. Let's define event A. We define A as the event of the product of the two numbers being odd. The product of the two numbers is odd. Then we define B as the event of the sum of the two numbers between 6 and 8 inclusive. Sum of two numbers between 6 and 8 inclusive. So those two numbers, the addition should be either 6, 7, or 8. Now back to the question. It says a student rolls two six-sided fair dice. The two numbers that appear on the top face of the dice are observed. So let's create a table to list out all the possible outcomes of these two six-sided fair dice. So this is die 1, and here is die 2. Die 1 has outcomes either 1, 2, 3, 4, 5, or 6. When you roll a fair die, you'll get either 1, 2, 3, 4, 5, or 6. Same for die 2. You get either 1, 2, 3, 4, 5, 6. Okay, so if you see it this way, then you realize that now we have all the possible outcomes for die 1, all possible outcomes for die 2. Okay, so if I toss these two dice together, I can either get a 1 on the first, a 1 on the second, or a 2 on the first, 1 on the second, or a 3 on the first, 1 on the second, so on and then so forth. Or I can also get a 1 on the first and then a 2 on the second. A 2 on the first, 2 on the second, and then I continue. 3 on the first, 2 on the second. All right, then go on. 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. Okay. 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4. 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. Then we have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and then 6, 6. Great. So these are all possible outcomes of tossing these two first six-sided die just one time. You can get either a 4 on the first, a 4 on the second, or a 5 on the first, a 6 on the second. If you count all these outcomes, there are 36 in all. So 36 total possible outcomes. Great. So what to find? The question actually is asking us for the probability of A given B. What's the probability that the product of the two numbers is odd, given that the sum of the two numbers is between 6 and 8 inclusive? So we want to find the probability of A occurring, given that B has already occurred. So let's show that B has already occurred. So let's find the two numbers whose sum is 6, 7, or 8. Okay, where are they? Here, 5 plus 1 is 6, so it's part. 4 plus 1 is 5, it's not part. 6 plus 1 is 7, so it's part. Okay, 4 plus 2, 6. 5 plus 2, 7. 6 plus 2, 8. Great. 6, 7, 8. 6, 7, 8. This is 5 plus 4, 9, so it's not parts. 6, 7, 8. Then 7, and then 8. Great. So we found all the possible outcomes whose sum is between 6 and 8 inclusive. So it's either 6, 7, or 8. Now, given that this has occurred, what is the probability that the product of the two numbers is odd? So amongst the ones that have already occurred, which are circled, let's find the ones whose product is odd. 5 times 1 is 5, so it's part. I'll cross it out like this. 6 times 1 is 6, it's even, it's not part. 4 times 2, 8, even. 5 times 2, 10, even. 6 times 2, 12, even. 3 times 2 is 6. 3 times 3 is 9. Odd is part. 4 times 3 is 12, it's not part. 5 times 3 is 15, which is odd, it's part. 4 times 1 is even. 4 times 2, 8, even. 4 times 3 is 12, even. 5 times 1 is 5, odd. 5 times 2, 10, even. 5 times 3, 15, odd. 6 times 1 is even. 6 times 2 is 12, even. So we realize that. Now let's find the probability of, using the definition here, all right? We want to find the probability of A given B. So it's equal to the probability of A intersection B. Where the circle and then the cross outline intersect is where A and B are intersecting. So that will be the outcomes for A intersection B. How many are they? There are 1, 2, 3, 4, and then 5. So the probability of A intersection B is 5 out of 36 total outcomes. 36. Then let's try and find the probability of B. That is the sum of the two numbers between 6 and 8 inclusive. Those are all the outcomes that are circled. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 times 4 plus 4, 3 plus 4 plus 2, 2, 8, 6, 5, 2, 7. Okay. So 1, 2, 3, 4, 5. This is not possible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 out of 36 possible outcomes for B. All right. So if you simplify this, you are getting 5 out of 16. So the probability of A given B is 5 out of 16. We have to consider 5 out of all 36 outcomes because the entire total outcome is 36. Okay. So this is the end of this example. If you look at your notes, you'll find that it's another example that you can give a try to. So I want to encourage you to give a try to that one, and then we can okay, so let's attempt to work on that a bit and let's see. Okay. I want to leave that one for you to give it a try, okay? And then we can discuss it later. Okay. Now the final concept we want to consider is the concept of under probability, the concept of independence. Great. If two events A and B are independent, then the occurrence of A in no way affects the occurrence of B. If I have a fair coin, I don't have a coin here. Let's say this is my coin, all right? I toss, I get a head. Second toss, the fact that I got a head on the first, will it influence what I get on the second? No. I may get a head on the first, but if I toss again, I cannot determine whether I'll get a head or tail based on my first occurrence. So those two experiments of tossing a fair coin, the first experiment and the second experiment are they are independent because the occurrence of the outcome of the first one in no way affects or influences the outcome of the second toss. All right. So going back to the definition of conditional probability, I want to change the form of this. So I'll cross multiply probability of A intersection B equals probability of B times probability of A given B. Okay. But the probability of A given B is still probability of A because the occurrence of B in no way affects what A happens to A. So if I ask probability of A given B, it's still probability of A because the fact that B has happened or not doesn't affect the occurrence of A. So this is equal to probability of B times the probability of A. This probability of A intersection B. So under independence, the probability of A intersection B is equal to probability of B times probability of A. I want to establish something here before we end this session. There's a concept called mutually exclusive. Two events A and B are mutually exclusive if they have no common elements. So A is equal to 1, 2, 3. B is equal to 4, 5, 6. These two sets, A and B, are mutually exclusive because they don't share any common elements. All right. So you can see that the intersection of both is 0. A intersection B is equal to 0. So the probability of A intersection B is equal to 0. So this is mutually exclusive is different from independence. Independence establishes that the occurrence of one event doesn't affect the occurrence of the other events in any way. But under mutually exclusive, it's stating that these two events share no common elements. So under mutually exclusive, the intersection of these two events is 0. But under independence, the probability of the intersection is not equal to 0. It's equal to something. Okay. So this brings us to the end of our lesson on probability. There's one example on independence in our notes, and we can work on that and then end the session. A student rolls a 6 fair die twice. There's one die. He rolls the first time, rolls the second time. The two rolls are independent. So we define A as roll a fair roll a fair die once. B as, so we define A as the first row of a fair die. B is the second row of the same die. Of the same die. It's a six face-sided die. Okay. Now we are saying that if these two events are independent, so the question is: a student rolls a six-sided fair die twice. The two rolls are independent. The first row is independent of the second row. Find the probability that the student rolls a 5 on the first row and a 2 on the second row. So first row of the fair die gave us a 5. Second row gave us a 2. The outcome was 2. So the probability of A is equal to what? 5 is just one outcome out of the 6 possible outcomes. So the probability of A is 1 out of 6. Because if you roll a fair die, you're getting a 1, 2, 3, 4, 5, or 6. And one is you can get 5 just once. So 5 is just one outcome out of the 6 possible outcomes. So the probability is one outcome out of the 6 possible outcomes. And the probability of B is also, we got 2. And 2 is just one outcome out of 6 possible outcomes, which is 1 out of 6. Okay. So given that these two events are independent, then the probability of A, we want to find the probability of getting 5 on the first row, 2 on the second row. In probability, the word and stands for multiplication, and the word or we use addition. Okay, so if you want to find probability of A and B, then I find the probability of A intersection B is equal to probability of A times the probability of B. And this is given as probability of A is 1 over 6, 1 out of 6. Probability of B is 1 out of 6. So 1 over 6 times 1 over 6 is just 1 out of 36. So this is our final answer. All right, so well done. Thank you for being a part of this session. You will be seeing your examples, practice questions soon, and then you will further discuss.